Whoops. Hello, everybody. My name is Eva Howe, and I'm with This.Labs, and welcome to GraphQL Fireside Chats. It is co-hosted by This.Media and Hasura. Our sponsors today are both This.Labs and Hasura. And we have one more upcoming events. The next one will be on May 12th, and we're going to be chatting about event-driven applications with GraphQL and serverless with Christian and Simona. Our guests today are Tanmai and Sean and Gago and Lee, who didn't quite get included in the slides, but is still very important. All right, let me close out, and Tanmai, I will let you take it away.
All right. Thank you so much, folks, for being here. And thank you, not very importantly, for joining us as, just creating the not very important technology GraphQL that we're all going to be talking about. So super happy to have you with us today, and hope everyone who's watching is, doing well, is staying safe, staying healthy. Today, we're going to talk a little bit about authorization and authentication, different patterns, different caveats, kind of tips and tricks and things that you've learned along the way when you're working with GraphQL. We'll start off with a quick round of introductions. I'm Tanmai. I'm the co-founder and CEO at Hasura. We've been working with GraphQL for the last few years. And one of the things that our users really like and that we're really proud of is the authorization engine. And so I'll have some interesting things to talk about there as well. And I look forward to this discussion. Would you like to go next, Gago?
Yeah. Hello, everyone. Everybody calls me Gago. It's not my real name, but it's the only way you can pronounce it. So we will use that. I work at Coursera. I'm in particular in the developer experience team, and I've been working with the GraphQL for the last couple of years as well. And this is it fits really well with time because we finalized our authorization system just a bit before this, so it was a good time.
Awesome. Sean?
Yeah, thank you. I think no one wants to follow Lee on the introduction, so thank you for letting me go first. I work at a company called OneGraph, and so OneGraph wraps a lot of public APIs like Salesforce and Clearbit, Spotify, QuickBooks in a GraphQL API and kind of joins them together. And that means that we have to implement auth again and again and again on the client side, and then also figure out how to propagate those permissions and controls to the end user. And so there's a significant amount of our time is kind of taken up thinking about how to do both authentication and authorization across our graph.
That sounds like there's going to be a lot to unpack there. Lee?
Hey all, my name is Lee. I'm an engineering manager at Robinhood and one of the co-creators of GraphQL. Almost 8 years ago now. Pretty wild how time has flown. And I'm also the executive director of the GraphQL Foundation. So I'm here to give a little bit of a historical context as we talk through all these questions about auth and why things are the way they are and how we solve some of the auth problems at Facebook.
Yep, I think this is going to be super exciting because I think all four of us come from wildly different kind of ways of using GraphQL. I mean, Facebook using GraphQL in its very particular Facebook way. I think at Coursera you have a GraphQL gateway that is kind of largely creating this right schema, but mostly federating to upstream REST services. Sean has a very unique use case with OneGraph where they're wrapping over public APIs and creating a public GraphQL API. So kind of more of a platform API use case rather than the client-centric GraphQL use case. And with Hasura, primarily, we've been focusing on a data-centric use case where we're looking at, bringing in data from databases and other upstream data services and creating a data API around that. And so all of these kind of different use cases are going to be very interesting to unpack. So maybe to kind of start this off, it'd be great to understand what the GraphQL stack looked like, and what the authentication and authorization part of the stack looked like just at a kind of high level, so that everybody can kind of create a mental picture of what that stack looked like and where auth was coming in. And maybe we can start off with Lee on what it looked like at Facebook.
Yeah, Facebook is a bit of a unique case. We had gone pretty much all in on a on a singular service. So we had this monolithic service built in Hack, running on HHVM, sharded out incredibly wide, and it was a complete software stack top to bottom. So being able to, that allowed us to make essentially completely not rely on auth at all. GraphQL didn't know anything about authorization or authentication. We could delegate that out to other parts of the stack. GraphQL is one piece of an overall API layer that we had as part of our software stack that comprised also a REST API, FQL, some webhooks, a whole suite of things. Those shared the same auth layer. So once you were behind that auth layer, then you could access any one of those various API endpoints, including GraphQL. And then authorization was the level below it. So all of our API layers, even though they took very different shapes, they all interfaced with the exact same piece of the software stack. At Facebook, that was called Ent, and it was a way of representing data concepts as a software system. And then creating each of these concepts. So every time you wanted to instantiate a user, instantiate a page, you would have to call some function that was well typed. And that function was responsible for making sure that you had the authorization to access that object. And we had a pretty sophisticated software system in place that allowed us to make guarantees about that system and run pretty conclusive provable tests against it. And so that allowed us to sort of completely divorce those two pieces. So we could completely focus on one piece of technology, which was the access layer of GraphQL, and one piece of technology, which was the permissions layer, which is part of that end stack.
Real quick, can I ask, you had pushed this all down to the system, and that sounds pretty amazing. I'm curious what that looked like for a consumer of GraphQL. For example, if I made a query and my user didn't have access to something, was that an error? Was it just a nullable field? Was that something I was supposed to deal with? Like, how did that actually look?
Well, that's a really good question, because there's lots of different shapes of authorization errors, and you have to kind of think carefully and from a product point of view what the right behavior is, not necessarily from a technological point of view what the right behavior is. So there's a difference between being able to know something exists, being able to read that, being able to see that thing. So for example, if you don't have permission to even know about a particular object, then returning back an error that says, hey, sorry, permission error, you're not allowed to see that, actually in itself is a privacy leak. And it's actually part of the reason why GraphQL defaults to nullability as in its access pattern, and it's a side effect of this property that exists pretty pervasively across all objects in Facebook. That knowing something exists is just as important as being able to access that thing in the first place. That might not be the right behavior for all systems, though. For some things, you actually do want to divorce those two concepts. You want to know something exists, and you want to know that you're not allowed to see it, and then that gives you some surface area on top of which you can maybe request permission or do other like application level or product level things to interface with that auth layer. So that pattern was a little bit more rare for us. In order to work around the default that we had, we would usually wrap that. So you'd have like a separate object that represented the idea of being able to know something existed, and you could read that object, and then that thing had a pointer out. And so that was a little bit of a hacky workaround, but it gave us an object with fields where one of those fields was like a pointer out to the thing, and then other ones could be ways that you could learn about what that thing was, even though you couldn't read it or ask for access permissions.
Got it. And could you help me kind of visualize what the code kind of looked like? So let's say a request hit the GraphQL server, and then there were like a bunch of resolvers that kicked in, and then all of those resolvers kind of delegated to the Ent framework that you had on the back to make the actual data fetch, and the authorization check happened at the Ent layer, or it happened in the resolvers that you were writing as a developer?
It happens in the Ent layer, and in fact,
okay.
Actually, even since near the very beginning of GraphQL, our resolvers were automatically generated.
Right.
So the actual all the code that gets run,
right,
95% of the time is actually a method on an object. So there'd be a class called Ent user, and that would be your user object on Facebook, and it might have a method called getName. And you would just create a mapping that says there's a GraphQL user type that corresponds to the user class, and there's a GraphQL name field that corresponds to the get name method, and then we generate your resolvers for you. And then there's two opportunities then to do privacy control. You do one when you instantiate the user. So if it's not me looking at my own user object, but maybe I'm looking up you, Tanmai, and maybe we're not friends on Facebook yet. And so in attempting to instantiate your user object, that fails and I get back a null. So you never like knew one of these classes. There's a class constructor like static method. And what you would do is you would provide in your authorization token, and you would provide in any like construction parameters. So in that case, it might be your user ID. And so I would say, I would like a end user, and here's my auth token. Here's what I believe is Tanmai's user ID. And I expect to get back either an end user instance that I could then call get name on, or I might get back null. So if I get back null, then like I can't even follow up with the name, and that's where it's going to end out the privacy check. Or maybe, you know, let's say it's not name, but it's your birthday. You know, I want to know your birthday, and you've changed your privacy rules so that I can't see that. Then I could load your user object, so that privacy check passes. But then in the course of calling, you know, get birthday, which is going to return, you know, some day, month, year struct, that returns null, and it's because there's a privacy rule there in place. And so methods then are responsible for applying that privacy rule. It's important because it means that privacy checking is not a property of the API layer. API layer is about gluing between HTTP and the internal system. But you also want privacy rules and authorization to happen within the internal system. So if you have some piece of complex logic that needs to, you know, load 10 people's birthdays and, I don't know, figure out the average age of your friend, you don't want that to accidentally incorporate data that was supposed to be privacy controlled. So that always happens below the API layer.
Got it. That makes sense. Gago, would you like to take a stab at describing the GraphQL stack that you have and, you know, how auth is kind of layered in?
Yeah. So we rewrote it almost a year and a half ago. So it's quite new. We already had one GraphQL. I call it. It had a feature that behaved like GraphQL, but it was just stitching a bunch of types together and exposing a schema, but it was all REST in the backend, or a form of REST that we have at Coursera. And we decided to take a stab at the new layer. And this new layer needed to include authorization in it. So we already had a service, and this service is fairly mature. Coursera has been working on this for a long time. And we needed to use that, but we had some differences in this space. We wanted to be schema driven all the way. So all the directives that were applied, we wanted to, even when we create new features, so you can have is a super user, or it has access to a particular course, or it's part of a class. We wanted that to be a feature that was part of the schema. So the person that was, say, protecting that query or that type will say, this only can be accessed by these features, this type of features that are in our authorization system. So then when a query or a request will come in, we will wrap every type, every resolver with type of, it will behave like a middleware, but it wasn't in the middleware layer. It was in the actual composition when you compose resolver to protect the resolver itself. So we will generate this concept of guards. Of resolvers, right? So that's how we will manage showing or not showing information. And as Lee said, we will just return no if we will not expose, oh, we had a thing, but we cannot give it to you because that is a privacy issue.
Got it. So I think the question that I have is like, is the primary use case of so it's kind of like authorization is happening in both places, right? So in the GraphQL layer that you have, there's also a form of authorization there that you're kind of wrapping over resolvers and stuff. But I'm guessing the REST APIs internally are also doing a form of authorization where you kind of, you fetch something like my courses, and I pass my user ID token to you as a header or something. And then the REST API will actually make the right data fetch call and fetch, precisely those users that belong to this current user, and and create the course list and stuff, right? So there's one authorization that's happening in the upstream REST service, and there's kind of one schema level authorization that is also happening at the GraphQL gateway. Is that correct? Is that correct?
It is correct. As all system is in transition, and you don't know what transition finishes, but because these services are also being consumed by an external API, they still have a bunch of rules related to how authorization happens somewhere else. So the entire process is forwards all the requests, all the valuable information for that request, so you can reprocess the authorization if that needs to be, and the service end up being the same. The huge difference here, it's about how you go about creating these rules around queries, right? So it's not that obscure. Oftentimes, authorization is a backend job that you just service. You give the information, you hope what comes back is what it's allowed, and we didn't want that to happen. We wanted a full-fledged authorization system in the GraphQL layer. So we will call this service, but we wanted all the rules so we can know what was going on. So we will not have to have any problems writing resolvers, and the resolvers would not need to know much about authorization. If the resolver gets executed, it's because you were allowed.
Got it. So can you give me an example of? So it seems like this would handle kind of mostly like coarse-grained authorization, where you don't need to like delve into the properties of the underlying fields and stuff like that.
These resolvers will part of the directives that we added could navigate the fields and have evaluation. You say, hey, we have these fields. So and that will rely on types. Everything is written in TypeScript. So we will rely on the types of the object that we knew that will be returned or not, to know if we can return or not.
So do you think it's a correct statement for me to say that eventually kind of the REST API that was fetching my courses on my profile page, the authorization that was happening for that would move into the GraphQL layer? Is that kind of the ambition?
Yeah. I mean, it will be messy if we start if we keep doing in both sides. I do think there's a use case for doing it twice if information is too sensitive and you need to do a different, more exhaustive analysis. That doesn't. We are not removing that.
Got it. Makes sense. Makes sense. All right, got it. And then I'll go next, and then we'll come to the extreme case of Sean, which is just this monster use case of Auth, right? The way we think about it at Hasura is there's kind of a declarative framework there's kind of a metadata framework that helps you compose models together, and these models come from either your database, or these models come from another GraphQL server, or it maybe comes in from your REST API as well. And so you kind of compose that model that can come from various sources, and then you attach rules to each of these models. And the way we've thought about it is, some databases have something called row level security. And so what we've done is we've kind of brought that model, that same kind of concept as a DSL at the Hasura level, right? So it's kind of, you're not actually, when you're working with Hasura, you're not actually thinking so much in terms of the GraphQL schema as much as you're thinking in terms of models and access control rules that each of these models have. And then the GraphQL schema is composed automatically on top of these models, and you have control over deciding, what the path of traversal should be, whether I want to fetch articles and authors or just authors and stuff like that. So that's kind of internally how Hasura is structured. And the authorization kind of rules are attached at a model level. So no matter what kind of resolver calls it, right, the right authorization rule for that model is kind of automatically used. So that's kind of roughly the idea that we follow. And this requires the developers to kind of specify their authorization controls in a declarative kind of DSL that Hasura provides. So that's the way that we've been thinking about it. Sean, what does the GraphQL stack look like?
Yeah, sure. So we're actually running in a language called Reason, compiling that to a native binary, which means that we have to implement most stuff kind of manually ourselves. And so we tend to work, each individual layer has its own security. So we make sure that the database is written in such a way that kind of all the permissions are pushed down into there. And then any of the handwritten resolvers also have to take into account the permissions that a user has and then calls into that. That said, there are kind of two separate permissions models. There's one for the resources on OneGraph. So this might be the apps that you've created, the organizations you're part of, and importantly, kind of the auth tokens that you might have provisioned. And these auth tokens are things that will allow you or your users or anyone who has them to access, say, GitHub or Spotify or whatever with some level of permission. And so for our internal property, so our kind of apps and whatnot, it's very much like Facebook's system where everything's pushed down to the system, everything is nullable, and we don't want to leak any information even about the existence of items. That said, on the other side, whenever a developer is trying to hit an upstream service, say GitHub through OneGraph, we want to actually identify the type of error message. So for example, it may be that this application has already auth on behalf of the user and is trying to hit some resource, and it can get some resources back, but actually it doesn't have permissions to get some other resource. And we want to actually normalize that and figure out what are the permissions that this application does need to ask for, and then actually push that to the user in a normalized way. So we actually kind of go the opposite way, where we actually try to expose as much as possible in a as normalized as possible way, right? Where we say, hey, the thing you just tried to do, turns out you need these two additional scopes, right? You need both write and read for Gmail in order to do this thing.
Right.
Here's the way to ask for it. Yeah, so I think that's largely the way that we've thought about it.
Got it. And when you think about like returning errors, because you're talking to so many upstream services, right? And a large category of the errors that you might see from upstream services are kind of auth errors, right? How do you send that back to the client? You just like mark that field as null and send something in the errors and extensions thing that gives the client a clue about like, that I'm missing a token or I'm missing a scope.
Exactly. So in the case where we work with like a partner and we actually wrap their API together, rather than say just pulling in an existing GraphQL API, we'll work with them to kind of make sure that the design is amenable to this, right? Because a lot of people initially, whenever they're designing an API, think this field is not nullable, and I don't want to have my clients have to deal with a nullable field. But then that makes for a very, very difficult time for error messages and for partial success and whatnot. And so if you can kind of hold their hand and walk them through and show the comparative cases where you say, actually, if you do make this nullable, then we can actually insert a error message and keep as much of the success as possible. And then we can kind of categorize the, typically there's invalid auth, there's missing auth, and then there's insufficient auth, right? So these cover actually the vast majority of public APIs, right? If your API is meant to be consumed by someone over the internet that has signed up, then you almost certainly have these classes of errors. And so we can kind of subsume those and then add in a little bit of metadata so that you can normalize the way that you respond to them. Right.
Makes sense. Before I kind of like maybe I have a few more questions to kind of delve into some more details. One thing that would help in setting context for me and I guess for everybody is who are the other kind of stakeholders that are involved in when it comes to auth, right? Like for example, I'm guessing especially Facebook would have had like a security team and like a privacy team, and they need kind of visibility and looking into these authorization rules and making sure that the right authorization rules are triggered and stuff like that. And so who are the kind of stakeholders that are involved, or who do you foresee the stakeholders being, and how are they impacted by your auth and GraphQL story? That'd be interesting to understand. I can predict what Lee's answer to this is, but still would be interesting to hear what the auth stakeholders were like at Facebook.
This evolved quite a lot over the years, obviously, as the company changed in different sizes. The first version of this layer, privacy layer, was built and owned by two people. One of which was Nick Strock, which was one of the other co-creators of GraphQL. So in the beginning, there wasn't really like teams and systems and people in place to maintain all of these various things as dedicated parts of their job. Now, obviously, as we grew, then it became more scaled up and you needed a lot more support structures in place. And some bifurcation of the organization did happen. Security team was involved to a degree, though really all they were looking for were anomalies. So making sure that we had a way to do anomaly detection and to have an audit trail was important. So we made sure that that was built into the privacy layer, not necessarily the GraphQL layer. The GraphQL team actually was able to remain fairly small, even while the company grew. In its origin, we were 3 people. By the time I left Facebook, the folks working on GraphQL was about 12 people. So we grew, but certainly not at the same rate that the usage of GraphQL was growing at the company.
Got it.
And the privacy layer did end up having a dedicated team. While it started as a small, like, one thing that was part of an overall team, there ended up being a team dedicated to, it was called, I think it was called Product Privacy Infrastructure, something along those lines. And they owned that, actually not even the entirety of Ent, but like the one piece of Ent that was the privacy checking engine. And it did ultimately include methodology for circumventing rules in an auditable way. So as someone who is sort of behind the scenes, you could, flip on the omnipotent or omniscient flags on your authorization token. And when you did so, you had to like give a reason why you were turning it on and what you were about to do. And all that went into an audit trail that was then like streamed over to the security team. And that was important to provide people the ability to do debugging when something would go wrong, and do it in an auditable way so that you could make sure, you were also like internally violating privacy rules in the process. Yeah.
Got it. And so, I mean, I know you've said this before, but with the GraphQL work and the auth work, it largely was almost entirely, they were largely orthogonal to each other, right? The GraphQL work was not impacted with auth. Like, were there any cases where the way that you were dealing with authorization, or the way developers had to deal with it, and the way the GraphQL API was being consumed, resulted in upstream changes to the way you thought about auth at all? Did any of that happen over time for any of those edge cases, or largely it just remained independent?
For the most part, it remained independent, although the one thing that was great is that the API contract that was put in place for Ent in, I think, 2011 holds true to this day, which is this idea that you want to construct a thing and you give it an auth token and you give it construction parameters, and like that's the whole contract, and that's true for every object. That's held. So that contract is what allowed GraphQL to be divorced from the authorization rules, because the authorization rules could all live below that layer. So that's been true. Though a handful of cases where I think it needed to get refined was scenarios where the authorization was unclear or ambiguous. So good examples of that are if you manage a Facebook page and you manage it with somebody else, understanding like who are you acting as when you comment, and the privacy rules for you as an individual versus the privacy rules for the page might be different, and knowing which ones to apply in which circumstances was complex, especially once you had abstracted authorization all the way down to like a single opaque API token that your iOS app has finally gotten from the API layer. It removed all nuance of that decision, and that required some later iteration. And we went back and forth between the idea of multiple auth tokens, and the client was responsible for providing one in each scenario. That had pros and cons, to an idea where the application layer itself includes knowledge about these relationships between things. And that also has trade-offs in terms of making the API a little more verbose. That ultimately we pushed it further in that direction. But it still ends up being a little bit of a blend of both.
Yeah, interestingly, we so my co-founder was also, I think, on the Relay team over at Facebook. So we may have inherited some of these practices, but we run into a similar issue where users may sign into multiple Google accounts, for example, and the permissions and the errors become a little bit more ambiguous there. And you want to make sure that you understand on behalf of which user that's currently authenticated, are you actually executing this call? And how do you want to handle the permissions at that layer?
Yeah, I think it's probably an even trickier problem for you guys at OneGraph, because there's a more clear disconnect between you as a person using a service and your various authentication roles. On Facebook, like the whole thesis was one account per user, and that one person then has exactly one definition of visibility. And that was mostly true up until the point of managing pages or The idea of like multiple identities, which was especially true for celebrities that we need to like flip on and off the celebrity identity. All kinds of like weird stuff happened in the product later that kind of started to blur the line around that concept. But yeah, I'm kind of reminded of this every time I have like 8 Gmail accounts for all the various things that I'm in now, and having to switch between them every single time I like load up a page and says like, who are you today? Yeah, this is a hard problem. It's hard from a product point of view, which means it's necessarily going to be hard from an API design point of view as well.
Sean, what does the security stuff look like for you? Like, what are the kind of non-functional requirements that you have around authorization and security, and how does that impact the work that you do the GraphQL layer? For example, do you have requirements around audit, or do you want to provide kind of the user a summary of what kind of scopes and permissions they have, and does that affect the way you've implemented auth inside the GraphQL layer at all?
Yeah, so it's actually maybe also related to your last question of what are the other stakeholders? Because oftentimes we see, we have a lot of like fun APIs like Spotify and NPM where it doesn't really matter what data you get out, it's fine. And we find that a lot of developers, they sign up for that because they see some demo and it's fun and they do a weekend project. And then there's also Intercom or Salesforce or something that they're supposed to be doing at work. And so they kind of migrate over and they're using Salesforce and they bring us into their company. And suddenly their company data is going through a third-party conduit. And the security team is not thrilled with this, right? And so whenever we talk with them, they need to know, what are our internal audit policies, who has access to what, which teams inside of their company are actually making use of this, which data is actually going through. And so that means that largely the audit requirement is much more like operational than it is kind of based, right? Where we kind of give them the controls to say, here are the requirements for accessing these auth tokens, right? You need to be accessed like on premise, or you need to be on the VPN or whatever it might be, so that they can control that. But then they need to actually audit that and make sure that there is some way of making sure that everyone who has accessed this data has had appropriate permissions along the way. Right.
Interesting. Makes sense. And Gago, what is like the journey that you've had from moving auth from the REST layer into the GraphQL layer? What was kind of the primary motivation behind doing that? And especially in light of the other stakeholders who want to think about security or have some visibility there, like, doesn't it affect their tooling? Because the REST APIs and the REST services have already had some tooling and practices in place, right? So that if there's somebody who wants to look at security rules or vet them, they probably have some kind of process or contract in place with the REST services, and now you have to translate that to the GraphQL layer. What has that journey been like?
Yeah, it's an interesting one. People get used to whatever you give them to work with, and then changing that habit is really hard. Just because I know how it works, why do I have to change it? Part of that effort is to understand ownership among who puts rules and who's maintaining that rule. Maintenance has been always a pain point every time that we develop software. Who owns this thing and who is responsible to making decisions about if this should be protected or not? Who is point person to say, all right, we're going to make this better or not? So that with going to every microservice, it was painful. Coursera, even though it's a young company or it's still a startup, getting bigger, it has like 1,200 microservices, and this is a lot to maintain. Yes, it's a lot. I know. That's the primary.
Like 1,200 API endpoints. I'm like, okay, that sounds reasonable.
Yeah, it is really crazy. This comes from historical reasons, but the presentation layer doing this, playing this role makes a lot of sense in this context in particular, right? You need a way of rule them all, a way of understanding how. I get a lot of the rings really fast, but you need a way of understanding how authorization is going to happen. Mm-hmm. In this layer. So we just work really hard on understanding how can we put a really expressive way of protecting these queries. Like I said, we had features, so you can say super user, or you can say it's allowed to this course or this asset or this combination of assets and these fields. Right. And the resolver would just operate auto-generate logic to protect you from that. And because it's auto-generated, you can do whatever you want at that point, right? It's like today we needed a better trail for this particular case. We just log more. We need to send some communication to the security team that is not that big. So the team that is developing that new feature can be supported, and that can be done as well. The idea here is to have a huge handle to be able to power up the authorization without being in the middle, being something that is obscure. Oftentimes it feels like you need to ask someone who has done it before to understand how you protect your queries. Are you protected by default? Are you always allowing by default? What is the here? So we needed this way. We needed a simple way of managing authorization, and so that GraphQL was an ideal candidate with powering up the schema.
Can I ask a kind of philosophical question around that? So, as you migrate the authorization to the centralized GraphQL layer, is the assumption there that the upstream service would never, ever be exposed directly to some sort of like public consumer? And if it were, would it be completely insecure? Like that's a failure mode that like it's a catastrophic failure mode.
Okay. Yeah, so exactly. So what you, that's a good question. While you're in a transition, this happens a lot. Like, so you cannot remove authorization from that layer because whatever that API and that microservices is doing today has to keep serving that external client. The GraphQL API that we have is internal. So we need authorization because of course, but we also needed to respect how queries were already working in the public REST API. So for this particular case, we will act, the GraphQL server or this layer that will query the microservice will act like someone who doesn't need to be questioned about authorization. If the request comes from this service, you assume that that service has rights to request this data, because we assume that we have a guard in the presentation layer itself. So this is handled in this precedent is already there in the microservice. It was already there. So we just took advantage of that feature to say, if I come calling, you just ought to answer, and we will just push that authorization to the presentation layer in this case. Does that answer your question, Chen?
That's super interesting. One of the things that, and I guess this is kind of like leading into my next question. Like one of the things that I've always liked about a REST API, right? A REST API is, from the database world, a REST API is like a materialized view, and GraphQL is like SQL, right? In just like changing layers a little bit. So basically, the idea is that when you're making a query to a REST endpoint, let's say I'm fetching like all of the data that's required for a page, and if I was like a monolithic system, what I could do is, because I kind of understand what data needs to be fetched for this particular page, a lot of the authorization checks, the way I deal with my authorization checks, a lot of that can be simplified, optimized, and kind of reasoned about. I won't say easily, but it can be reasoned about at the REST API resource level, right? And I guess the way, if I understand correctly, the way the way it happened at Facebook was that authorization rules were kind of at the end model and field level, which meant that the GraphQL API folks were largely kind of not worrying about how auth and data fetch and all of that kind of work together. Whether the how we need to optimize the rule engine, right? Whether we need to run the 4 rules and then run the data fetch, or whether we combine them together, and we don't need to worry about all this. But as the GraphQL API team, right, we just build the right API for our product. And that's largely what we concern ourselves with. I mean, I don't understand again if this is right, because the GraphQL API itself was auto-generated, but that's the sense that I get. And it seems to me, even from the work that, in our case, like we stumbled into GraphQL, right? But even from the way that we think about it, for us, it was important to, even the nature of an API and the nature of like a platform API especially, is that you think in terms of like models, and models have privacy rules attached to them, or privacy functions attached to them, and that's just much easier to think about than thinking about when a particular set of resolvers are kind of dynamically composed, you have to pass the right authorization information, and then maybe you're doing a lot of extra authorization work, because like authorization and data fetching is so close together sometimes, right? That you'll be making a lot of redundant calls for doing the authorization check versus the data check, right? Especially imagine that you're fetching lists of objects, right? When you're fetching lists of things, you don't want to check like per row, right? You want to make a query that fetches a list where, course.owner ID equal to user ID. So all of this is much easier to think about at a model level and even at a REST level, but it becomes harder if you bring that to the GraphQL layer. Is that understanding rightly? And if that understanding is kind of right, if you want to add some nuance to it, we can pass it on to Gago and Sean to understand, how they deal with this conflict.
I think that understanding is right. And I really like the way that you framed that up, that thinking about it interwoven with something akin to a SQL query, it's just hard to wrap your head around, and tying it directly to either at a model level or even to be more granular at a field of a model level.
Right.
It's just much easier to think about that. It's like, the ingredients going in, the ingredients going out. The ingredients going in, it's like, I know the kind of model and which one specifically it is, and I know who's looking at it, and I just want to end up at a yes or no answer. And it's just way easier to think about that than like thinking about lists or joins or fan outs or hops between services, and like interweaving that and trying to be smart and come up with like the most performant way to go about it. It's just, you're just going to end up like, it's way more important to be correct than performant when it comes to authorization. And the nice thing too is that if you set up your architecture to have certain high level constraints, then you can do whole program or whole architecture optimizations that you couldn't do if you tried to be clever. And so in our case, a handful of things that looks like. So one, kind of to your point of sometimes authorization needs to do fetching, and that fetching needs to do authorization. Like, yes, if you wanted to know, I want to, load Sean's birthday, to go back to that example, I would first have to load some bit of data to know, has Sean blocked me, and I can't answer yes or no until I've loaded that data from some backend service, which is a different service than the one that's like doing the auth check. And so, when you need to asynchronously load data before returning your asynchronous Boolean result of a privacy check, you better be A, caching that stuff aggressively, and then B, memoizing that stuff aggressively. So having caching and in software memoization at the ready makes those things dramatically faster. So like to your example of a list of things, if you have a list of things and they're a list of very similar objects, so say I want to load a photo album of pictures that you took over the weekend and you posted up a dozen pictures, and it's absolutely correct that I have to not only do a privacy check on your post, but I also have to do a privacy check on each photo in that post, because you could have gone in on one of them and tweaked the setting. But if you didn't tweak that setting, then we'll quickly find out that the privacy rules for one are the same as all the others. And so instead of saying, can I like do some smart thing and check for privacy for this whole list, I can say, can I see that photo? It's going to do some work. It's going to say yes. I'm like, can I see that photo? It's going to go, oh, I've already done that work. Memoized, yes, instant.
Correct.
And it's going to do that for all the rest. And so having those rules set up at the system boundary means that we can still have incredibly performant authorization checking. Also, by tying it to the model, we make the model the source of truth, rather than tying it to SQL or GraphQL, rather than making the query the source of truth. If the model is the source of truth, we become less beholden to GraphQL specifically, which means if we need to have a REST manifestation of that model, we can do so and be guaranteed that we'll have exactly the same privacy rules that we'd have with GraphQL. Or if we wanted to have service communication, again, we could be guaranteed exactly the same privacy rules, because it doesn't matter. As long as those things are all talking to the same model, they will all be guaranteed to have the same authorization constraints.
Correct. And I think that's kind of largely been our feeling as well, especially because as we're kind of working with customers, especially on the enterprise side, right? It's people. The entire domain is kind of like the entire business, especially large companies, right, are set to talk around models. They talk around even forget the product, right? Even like most of the APIs that we see in the world today are, I mean, 1 or 2% of the APIs that we see are actually APIs for front-end consumers, right? But most APIs that exist are all internal APIs. They're all service to service, business to business, right? And everywhere people are just thinking in terms of like, people like thinking in terms of models, and those models have properties. You have dedicated like staff or team that like looks at the security for those models, who was privacy here, was privacy there, right? And so it kind of feeds in more naturally for the authorization logic also to be kind of tied into the model level. And so how does that thinking affect the work that you were doing, Gago and Sean? Yeah, I mean, Gago, you can go first, and then I mean, I'm just randomly assigning people, so there you go.
So the question was, how's people work with these rules?
Yeah, how are you thinking about the rules instead of being at the model level inside the REST API, or like I don't know, like I don't know how it works for you in the GraphQL to REST transition. Yeah.
So because we were moving for something that existed already, it wasn't much of a decision that we can make. It wasn't like we couldn't rewrite the world and decide, all right, it's going to be tied to models. Were hard in this sea of services that we had. So which model is like course? There are like 50 courses. So like that are not necessarily the same. So we pretty much did the type for us was the model at this point. The type in a GraphQL layer was the model.
Right.
Like Lee said, there are bad things about it. Like it ties you to GraphQL a bit. The good part that I find, the upside of this is when you need to understand performance, like we were doing memoization and aggressively cache for this authorization service, so we can just always ask the damn question 50 times or 100 times, and it doesn't matter. It will be performant. But the part that I found really nice as a product engineer, not being one, but thinking like a product engineer, is that you could understand the implications of checking the permissions for a collection that you have. So you get the side schema in that way, because now the schema is the one that it's the actual model. So you can put rules, you can create a connection there, and that connection has different rules. So you can put authorization in that connection, and that anywhere where that connection is going to get used, it will have those authorizations. So you can protect that particular thing to accelerate the authorization. If you were able to have that problem, I don't think we haven't had that problem yet.
So maybe like if I can ask the question, right, which is like, if you think about like users, and users have courses, right? And so maybe I can make a query to fetch courses at the top level, or maybe I can make a query to fetch users and their courses, right? So in terms of the GraphQL schema, these will show up like there'll be two resolvers for courses, right? There'll be like a top level resolver that you have for courses, and then users inside courses will have another resolver attached to it, right?
It will call back.
Got it. So
right.
Okay, so the way that you will specify like your rule, so you will try to specify like your authorization rules at the courses level, and then make sure that you do the reuse, so that however that course's entity is accessed. I mean, what I find confusing is because and this might be my misunderstanding, but it seems like your GraphQL schema is kind of more structured around resolvers than like each type is actually like representing a it's kind of more like resolver driven and resolvers written types, right? So even though you're returning courses, the path with which you return courses might have a different function that returns courses. Am I making sense?
No, it's always I think I understand what you mean. It's always the same. Right. Courses has every field is independent. Every field is independent inside courses. So every field of name, it's independent. We have a layer of a data sources. Just to get into our architecture, we have data sources, and these data sources are really powerful. So they talk to these microservices in themselves, and they have cachings as well. But they are independent. Every field is independent from each other. So you can execute only the name for a course without requiring a course as a thing. So that gives us the plasticity of not worrying about what happens. Do I have to load everything? That is not a decision you have to make anymore.
Got it. Interesting. Very interesting.
Right.
Sean, how do you think through these kind of design challenges?
Can I actually first just clarify? I'm curious because when you were mentioning the model versus like a materialized view versus SQL,
Right.
So Lee, at Facebook with the int framework, an int is a model effectively, but you still have permissions on fields, right? Like a birthday might be perhaps a protected field. So you still have to specify permissions down at the field level.
At the field level, yeah.
The execution of that is just kind of abstracted away from you.
You have the option to. So there's the ent layer, which is the model, and the ent layer as part of the class. So it was originally designed as PHP classes before our migration to Hack, but they're essentially class models. And you're required to provide a static method that you subclass this ent thing. And there's a couple of abstract methods you got to fill in. One of them is how you actually get that data from a database. And that's also kind of tied to data loader. The data loader idea actually was derived from how that thing operates. And then the other static method you have to provide is called can-see. So can-see gives you, it's like a step in between. So it's like you have the data fetched, some of the data fetched from the backend, but it's not fully resolved into the class model yet. So you have raw data, and then you have all this input, and it's an async function, and you have to eventually return back out true or false. So in the early era, then it was just people manually writing that code. They were just like doing stuff, and eventually some common functions got evolved out of that, and people were reusing these common functions. But it's still a little too easy to get wrong. There's nothing provable about something like that. So later a system was built called privacy policy. Privacy policy let you define rules where there was like a very clear abstraction in place where you would say like this rule executes by taking in these input parameters and like succeeds in this case and doesn't succeed in that case. And then you could unit test individual rules. And then rules could be reused for like, hey, has Sean blocked me is like a rule. And I can reuse that rule in many policies. And a policy is a sequence of rules. Some rules either say they deny, like you can't see that thing, or they pass and they go on to the next rule. Some rules will say grant, or they'll pass. So like, is this person a super user is like a grant or pass kind of rule. And so those will go down. And once you sort of boil it down to those essentials, you can do a bunch of really smart things. Like you can see, well, the next 3 rules all either deny or pass. So I'm gonna start loading their data simultaneously. And if any one of them checks, then I know I can deny. Whichever one comes back first, I'll do that. And so you can then, like, as time went on, more and more sophisticated wizardry was thrown at that thing in terms of making it more performant. But the nice thing is now that thing is an isolated system. All it needs to know about are checking rules that return, deny, grant, or skip, and how they come together. And now that thing you can just like stick in place in that can-see method. So it's can-see says like, hey, I want to know based on this raw data, can you give me back true or false? And it would say, okay, defer to this privacy policy. And later Ent made like some nice syntactic additions in the code base in order to make it easy to say, okay, here's my Ent that defines my model. Here's my privacy policy that defines my authorization rules. And like these two things go together. But because they're separated, you could use privacy policies anywhere else you wanted to, not necessarily just in model layers. So that's how originally at the function level, if you wanted to say, do privacy checking for a birthday, you would have to make sure that function was going to return, it was going to be an async function or a method rather, class method. And then you'd have to manually do that work. You'd be like, all right, birthday, I can't just return an answer. I got to like do this work first. And then if I've somehow managed to call my functions correctly and I've decided that they have permission to view this thing, then I'll actually like look through at my, in-memory representation of this model and yield that value back out. And so like, again, you can put the privacy policy in place and you can say like, all right, I want to get birthday. What it'll say is like, if privacy policy passes, or if like await privacy policy passes, then return birthday, right? And so you can simplify that logic down to something that you look at, you're like, that can't possibly be wrong. And then you can unit test and like provable test to do all kinds of other kinds of tests on the privacy policy itself, which allows you to then divorce those concepts and apply them where you need them.
Yeah, that sounds familiar because the way I tend to think about it is you do want to have permissions specified at a field level, right? So a birthday may have different permissions than just a given name or your online status or something along those lines. But I feel like the way that we typically build GraphQL servers is kind of at the wrong abstraction layer. So it's very manual, very fiddly, like you're kind of talking about with building those rules into the individual functions. And so this means that it becomes very difficult to kind of audit for a single human being to kind of look at the potential exposures or the potential issues. And because of that, the coarse-grained nature of like a REST, a single endpoint and kind of saying yes or no for a whole endpoint feels a lot more maintainable, right? A lot more like understandable initially. So my hope is kind of that as maybe the wider community grows more experience, like Facebook did, some of those better practices will kind of populate upwards, so that we'll have the ability to specify at the field level, but also to do that very, very succinctly, very quickly, and very auditably. Typically how I tend to think about it.
I think that's right. And what I've realized in hindsight is the path of how you get to these things is more important than the like end result. Yep. That, for Facebook, we didn't transition endpoint to a GraphQL endpoint. We transitioned from like an internal PHP web application that had no API. It was just like the only API part of it was that it yielded HTML at you. And then it was like, okay, how do you build a mobile app? And it's like, oh, well, you probably shouldn't be consuming HTML. What are you going to do? Like write regular expressions to like extract the stuff out of there? Probably the wrong thing. And so it was only at that moment that we were looking at what the right product API should be. And then rather than like transitioning from an existing API, we were looking back at what we had in our PHP layer and saying like, man, if only we could just take our PHP product development environment and take it to mobile, that would be great. Which is a very different place to come from than if you've already been building mobile applications, you've been building them with REST APIs or direct SQL or some other API abstraction that has that authorization pattern that you mentioned, Sean, and then you transition to GraphQL. I've talked to a bunch of people about this. This is one of the very first and most frustrating things that they hit is they find out that whatever, their Ruby backend or their Python backend or whatever, has like the way that the REST API was abstracted, divorced the idea of authorization and model and put the authorization on the network route boundary rather than on the model boundary. And it said, okay, if you want to load /API/v1.0/user/UUID, then like here's the function to call that decides whether or not you have access to that. And if it's false or whatever, we'll send you the appropriate HTTP code, which is great. And then if true, here's arbitrary function to call to return data. And it's like, you better cross your fingers that you've written your SQL query correctly and you haven't leaked some information. And anyone who's built an API this way, go talk to folks at like GitHub or Shopify or anyone who's been in that world for a long time will tell you that it's super easy to screw it up. And you have one endpoint that eventually you start out with like one model equals one endpoint, and then as you evolve things a bit, the lines start to blur a bit, and you're like, okay, I'm going to give you just a little tiny bit of data from that model because it's super common use case, and if you need more, then you can load it over there. And you find that like the access rules for each endpoint differ, and then you can like find bugs by working around and finding access to some piece of data. That's not great. But then the transition from that to something like GraphQL becomes super challenging, because not only do you have to swap out your API technology, you realize that in doing so, you also have to swap out your authorization technology, and that's way harder.
Yep. And I think the way, like, I've seen this problem come up as like with REST, generally with REST frameworks, because it's been a while, right? It's been like so many years. People do auth at many different layers, right? So some people kind of put an auth at the routing layer, right? Like who has access to what route is like a subpath, and we'll determine based on your token whether you have access to this path or not. Or we can put it in the controller, or we can put it in the model, right? Like, and it's very flexible, and everybody just kind of does, I mean, flexible in not necessarily a good way, but like people just kind of do whatever they want, wherever they want, right? And then suddenly when you come to GraphQL, you realize that, oh, I should have been a little more systematic about this, because now suddenly that complexity is kind of exploding my brain, right? And so that's been interesting. But one of the other things I find fascinating about this interplay between authorization and data fetch, because it's such an interesting problem that, like, not just from a security point of view, but also from a performance optimization and caching point of view, right? Are things like, for example, there's a certain transactionality that sometimes you need to have in a query, right? Like, for example, if I'm fetching like my friend's information, and I fetch like on Facebook, and I fetch your friend's information, and then I make an like the same GraphQL query also has a photos request, but by the time I made that photos request, you had unfriended me, and that took a long time. That happened in the background. Maybe the way I fetch your friend's information and default profile photo will leak out more information than what I should have gotten in your photos. And that again is like a brain exploding thing, because you're like, oh my goodness, like that transactional violation that a data layer would handle for you, that databases are kind of increasingly trying to do now, is becoming like that's again something that you have to think about. And this is kind of what I was saying is easier to think about with REST, because with REST you're like, I know everything that needs to be returned, so I can create a context for myself that is safe in this everything. I can create a safe authorization context for this entire resource. So it's easier for me to hack together a REST endpoint than it is to build a systematic GraphQL endpoint. That's kind of what I was going for, Sean. I don't know if that makes sense.
Well, I think there is a direct analogy that we found really useful, which is persistent queries. And I think the Twitter team, the TweetDeck team, makes excellent use of this in like many different ways. So they did, they had a great talk at one of the GraphQL conferences a few years ago, where they talked about both they're concerned about data being leaked and also very expensive queries being run. And so during development, I can run whatever query I want. That's absolutely fine. But whenever the build runs and we're trying to go to production, we're going to actually persist each of these queries out to the server where they can kind of be analyzed, right? And so this gives you that kind of a direct analogy where you can say, what are the security implications of this? What are the entire auth required for everything inside of here? What would be the entire data fetch that I need to do? How do I optimize that? And you can kind of push that down into an execution engine so that as a developer, I get to just run free and do whatever, but then I never expose my users. The challenge there is it still does require that someone has been thoughtful about describing the permissions at a field level. And so I think that is maybe more work than people are initially prepared to do. So definitely, I mean, to Lee's point, the journey of getting there, of saying, you are actually going to have to think about this at a more fine-grained level for all of this to work in a really ideal way. That can sometimes, I mean, just like, Stitch in Time here, like we often want to put off a lot of that work, right? It's hard to get people to do things that may or may not be valuable, in the medium to long term, versus just doing what is absolutely valuable in the short term.
Yep. No, that's true. That's true. And I think the persistent query strategy is also very interesting. It does require a slightly different schema design, and like it requires you to kind of maybe make sure that the arguments surface up in a way that you can describe a persistent query and just leave a variable out in a particular way that integrates with your authentication system well, right? Like it does require a little bit of work on the design, but then it's a convenient model as well. We're kind of out of time, and like we could like auth and GraphQL is a topic that I think we can just like keep going down a rabbit hole forever. And so hopefully sometime in the future we'll have another one of these and get to dive a little bit deeper into these topics, and I'll try to do a small blog post summarizing some of the really good conversations here, and maybe we'll have that out soon. But before we kind of wrap up, I would just like to ask everybody what their picks are. Any technical, non-technical, quarantine busting tips, whatever. Gago, would you like to go first?
I don't know.
Also, I must ask, Gago, how do you pronounce your actual real name?
Oh, are you ready for this? It's not that hard. It's just that the G is weird. So I'm from Argentina. So my name is Germán.
Oh, Germán.
Not Herman. It's not Herman. It's Germán.
It's like the
yes,
like, all right, got
German,
it.
right?
Like you've okay, yeah.
Right. But if you write it down, it looks like German. So when someone calls me German, I feel I represent a group of people that I'm not necessarily related to, which is super weird. It's like I'm sorry, I had nothing to do with this. So I tried, and Gago just came up when I was in high school, and I just it's easy to pronounce at least.
Yeah, that's true. That's true. But yeah, picks.
Picks about what? About the quarantine?
Anything. Go for it. Quarantine busting tip.
I'd be happy to go first if you need.
Yeah, you go first. I need to think about it.
All right. So my pick is the Relay GraphQL client. So I was initially very skeptical of this. I was like, oh, why do we need this? Especially like having seen the old Relay Classic, and I was like, my goodness, like who needs all this connection nonsense and whatnot? And then, again, so just like it takes time for people to learn to do what's good for them, I eventually put in some time because of my co-founder, and I realized that everything I had been struggling with, or the vast majority of things I had been struggling with from a client-side point of view from GraphQL, is because I was ignoring what Relay was trying to do. So I recently got deep into it and wrote a couple of articles with a friend of mine on it, and suffice to say, I am super impressed. Relay Modern is just an absolutely fantastic GraphQL client, and I don't wear the Relay shirts like my co-founder does, so I think you can trust me whenever I say that I think it is actually, if there's anything that you're worried about in terms of like, should GraphQL be behaving this way, I feel like I'm kind of struggling. It's either because you're not using Relay or because you haven't conformed to some of the things that Relay would like you to do, in which case a lot of the problems will go away. So strongly recommend revisit and check out Relay. It's, especially with the hooks-based approach, it's just a joy to use.
To kind of add to that, with I spent another 2 weeks with Sean and Gabriel, who are the two people who worked with Relay, and I understood Relay, and then my mind got blown because I now feel that if you're using GraphQL without fragments and without the way Relay uses fragments, you're doing it wrong. I have like my opinions just changed. We're also announcing Relay support tomorrow for Hasura, so
I've been talking about it.
Yes, but anyway, Gago, do you have your pick now?
I needed to think about it. Yeah, Relay, it's interesting. I'm not going to talk more about Relay. This is too many fans in the same room. So, Sean, you guys are already selling it. So I think my pick is it's all the things that the Guild is doing in the space. I've been using their software. We are talking about GraphQL modules. We are talking about GraphQL code generator in general. And I find it really powerful. It's well written, it's well maintained. The code is easy to read. They write a beautiful TypeScript. And I think there's value in ideas, fresh ideas, and there's a value in people who works for the community so much. So I like that type of product and that type of effort. So that is my pick.
That's awesome. Lee?
Man, I want to second both of those two picks. Both excellent. Obviously a Relay fan. I worked on that team for a while. It only gets better with time too. And the Guild, I'm a huge fan of the Guild. They produce such great things. My pick, I want to represent VS Code Live Share. I don't know how many people have used VS Code Live Share. It's been out for a couple of years. But I just started using it recently. The idea of being like locked in our houses, I kind of missed being able to, hang out around one computer screen with my coworkers. And it lets you, it's basically like a massively multiplayer online game, but for nerds building stuff. It's a lot of fun. So we've been kind of experimenting with it recently, doing, live coding and pair programming, and it's been a joy.
That sounds pretty awesome. My pick is that we are going to be hosting our first UserConf, which is happening in June. We call it HasuraCon 2020, and so join us for that. I think we've probably just announced it on Twitter, and that should be super fun. Incidentally, Uri is going to be there as well, and he's going to be talking about some interesting use cases with GraphQL Mesh and Hasura kind of combined together for some fascinating stuff that happens. Sean will also be there. What's up, Sean? But yeah, that's please do check that out and join us for that. And otherwise, see you online. That's a wrap from our side. Thank you so much, Lee, Gago, and Sean for being here. And see you online.
Thank you.
Thank you. Have a good one.
Bye.
Bye-bye.